In the dense forests of Taiwan, hidden within the decaying heartwood of the camphor tree, a rare fungus quietly thrives. Antrodia cinnamomea. Once revered by indigenous healers for its restorative powers, this crimson fungus has now captured the attention of modern science for another reason. It may hold the key to reversing the biochemical chaos of obesity. Obesity, once seen merely as a matter of excess food, is now recognized as a cellular disorder, a disruption of the body's own metabolic orchestra. Deep inside fat tissue, immature cells transform into lipid-filled adipocytes, swelling and multiplying under the influence of two master regulators, PPAR-gamma and CEBP-alpha. When these transcription factors ignite, they summon enzymes like fatty acid synthase, FASN, and SREBP1, flooding the tissue with triglycerides and cholesterol. The result is not just weight gain, but a systemic imbalance that ripples through the liver, blood, and gut. Scientists from Taiwan's National Defense Medical Center set out to test whether extracts from Antrodia cinnamomea, specifically its alcohol extract, AC, could interrupt this process. What they discovered reads like a molecular redemption story. In cultured fat cells, AC acted as a biochemical brake. It blocked adipogenesis, silencing PPAR-gamma and CEBP-alpha, and activated AMPK, the cell's energy sensor. With AMPK switched on, the cell's priorities shifted. Energy was conserved, lipid synthesis halted, and fatty acids were burned rather than stored. At the same time, ACE quieted the MAPK signaling network, muting ERK and JNK, the very pathways that push fat cells toward maturity. In living mice, the effects were profound. When fed a high-fat diet, animals ballooned with visceral fat, their livers turning pale and greasy with fat droplets. But when ACE was added to their drinking water, the transformation reversed. Weight gain slowed, liver enzymes normalized, and the telltale lesions of fatty liver disease faded. Even under the microscope, their adipocytes appeared smaller, leaner, as if the fungus had whispered restraint into their metabolic code. The researchers didn't stop there. Using RNA sequencing, they uncovered that ACE reprogrammed gene expression in fat tissue, silencing lipid-building genes like SED1, ADIG, and AKAKA, while elevating those that favor fat oxidation. In the gut, ACE sculpted the microbial landscape. Akkermansia, Bifidobacterium, and Turicibacter, bacteria associated with leanness and anti-inflammatory balance, flourished, while harmful Escherichia shigella retreated. Together, these findings suggest that Antrodia cinnamomea doesn't fight fat through one single weapon, but through a network of biological rebalancing, rewiring metabolism, calming inflammation, and restoring harmony between host and microbe. In a world drowning in metabolic excess, this humble forest fungus reminds us that nature's solutions are rarely simple, but often profound.